Good afternoon, everyone. My name is Jay Haridas. I'm one of the dev managers on the Windows Azure Storage team. I'll be covering about Windows Azure Storage. Mainly, I'll give a quick introduction to Windows Azure Storage as to what it is, what are the various abstractions that we provide for your storage solution. And then I'll go into what we recently released in our over the last couple of weeks. And then I'll get into the key concepts, which will give you an idea of what the underlying abstractions are and how you can write scalable applications. And then I'll cover some best practices that will allow you to scale your applications, or some of the best practices that will help you build stable applications as such. And then a future direction as to where Windows Azure Storage is going towards. Before I start off, I just want to get a quick hand check on how many of you have used Windows Azure Storage. Awesome. That's great. So for those who didn't raise their hands as such, I'll give a quick introduction and maybe a quick demo example as to how you can get started. But I want to cover as little as possible on getting started because I think our MSDN documentation already does a great job on covering that aspect. But I will still go through a sample app maybe which will allow you to understand how you can start using storage. So quick introduction. What is cloud storage solution? What is the Windows Azure cloud storage solution as such? It provides you anywhere, anytime access as long as you have internet access, which we dealt with yesterday. It's highly durable, available, and scalable. By that, we mean that it's durable because we store multiple copies of your data. Whenever you store data into Windows Azure Storage, we make multiple copies of those. It's highly available because those multiple copies are stored in such a manner that it can withstand certain common failures like network failure, node failure, upgrades where the node restarts. So it can withstand certain common failures. And it's massively scalable because there's an auto load balancing component in Windows Azure Storage, which will look at the pattern, your traffic pattern, and then load balance the partitions, what we call, and I'll get into more depth into what a partition is. But it'll load balance this to meet your traffic demands. So any hotspots, it's just going to load balance so that these hotspots can be taken care of. All these characteristics allows you to build internet scale applications very easily. We have over 300 petabytes of raw storage today, and it's growing at a fast pace. In addition, there are various applications which are having peak traffic of more than 40,000 requests per second. So there have been all these applications running in Windows Azure Storage feeding that many transactions per second. With all those characteristics, the other differentiating factor from conventional systems is you pay for what you use. In a traditional system, you would know that when you have this concept that I want to build a scalable application or the scalable web app, which needs this much storage, you would go ahead and do your capacity planning. You would purchase your hardware so that your peak traffic demands can be met. And you would start to invest before your application actually goes live. With Windows Azure Storage, you pay for what you use. So you can start small. So you pay for only the resources that you're utilizing. And once it becomes really famous application or it goes viral and you get more users on your application or you want to build this prototype into a concept for your product, then you would start utilizing more resources and you start paying for whatever you used. We provided easy to use and open REST API. It's well-documented REST API, so you don't have to kind of use our client libraries. But we understand that many of you don't want to go to the depth of the REST API, so we provided certain client libraries in various languages because we truly believe that cloud is language agnostic. So we have Node.js, Java, .NET libraries for you to access the storage solution. So to quickly go through, we have a few abstractions for cloud storage. One is your blobs, which is your simple files that you can store in storage solution in storage, and then associate metadata with this. You can think of using this to store your enterprise documents so that everybody can have this durable access, highly available and scalable access to your blobs from your enterprise. Or you can think of building social networking apps on top of it. So you can share pictures and stuff like that, and I'll go over various ACK-Link solutions that are present today. Big data analysis. Almost every company wants to invest into utilizing the data to understand how they can improve the efficiency of their own company or the product, or even for better ROI. And so big data analysis, you have a ton of raw storage capacity. And so you might want to start storing that in the cloud storage solution and then use the compute capacity available in the cloud to go and digest that information to get analytics information. Backups, that's another common scenario where you may want to back up your device, your cell phone device, or you want to back up your tablets or whatever it may be. You want to start backing up your music maybe. And so that's another kind of application out there that you can start thinking about building on storage blob solution. In my personal opinion, I think to build a scalable application, you almost always tend towards a NoSQL-like app or demand or other structured storage solution as such. And so we have the stable solution, which is a NoSQL structured storage, which auto-scales. So you don't have to manually shard your data. There's nothing where you have to go and figure out, okay, where's your hotspot, and now I have to kind of shard this relational database or something of that sort. So you don't have to get into that. The NoSQL solution provides you fast access where you can shape your data so that you can start to retrieve it in a very efficient manner. Common use cases is basically, you can think of your social sharing app, social networking apps which want to store your user database or the content data and stuff like that. That's a common scenario where you can start using your NoSQL solution. The other solution, the other thing is key value lookup, where you want very fast access to your values for a given key. So even such solutions can be built on top of tables. Queues. In a distributed system, you want these components that need to communicate with each other. You want to decouple it because you don't want a failure in one component to impact the other components. And so asynchronous messaging, that's what it provides. Queues provides asynchronous messaging. For example, your web application may take a blob where you upload your blob, and then you want to go and process this video or image, and that can be done asynchronously using a queue. So when you upload the blob, you would insert a queue message, and then you'll have a worker role which goes and processes these messages to process the blobs. You can also think of building workflow or process flow-like applications on top of queues because it's asynchronous messaging at the end of the day. Disk and drives. This solution provides you an easy way to move your legacy applications that you have today into the cloud, because what it is a network-mounted durable device. It's fixed formatted VHDs that you can now load in the cloud, in the compute nodes, and now start to run your legacy application that uses NTFS APIs maybe. So we have those abstractions. The disks and drives, one thing I wanted to mention out there is it's built on top of blob storage. So it's this logical abstraction that is built on top of blob storage, and I'll get into more depth of that, into that. So let's look at Windows Azure blobs. When you sign up for your account, what you get is an endpoint, which is account.blob.co.windows.net. So you created your account. Once you have your account, you can start to create all your containers. Once you have this container, your folder basically, you can start to store all your blobs in it. I'm quickly going to skim through all the APIs. You can always look at the list of APIs through MSDN, but we obviously give you a way to upload the blobs, download the blobs. But the interesting APIs are, there's an asynchronous copy now, which allows you to copy blobs between storage accounts or even copy blobs externally. There's a very good blog out there which talks about how they've copied a blob from a different provider into Azure asynchronously. So there's this asynchronous copy mechanism, and then you can think of snapshots as versioning. So your application, you want to protect your application against your own application faults, so you may want to snapshot your blob whenever you update it. And so the snapshot provides you this versioned, read-only version of your blob. So when you take a snapshot, it'll create a copy a read-only copy of your blob. There are various sharing scenarios. By default, every access is private, which means you need your storage, along with your storage account, you get your storage account key. You need to sign those requests by default. But we have public access, where you can set your container to be accessed publicly, or you also have shared access signatures. In addition, we've also introduced leases on container, which is a new thing. And leases were always present on a blob, but we made some changes to it. For example, leases by default were 60 seconds before. Now what we've done is we allow you to have this granular lease between 15 to 60 seconds. Or we've also provided this lock concept where you can acquire an infinite lease. So you can think of building this distributed lock as such, an application that requires a distributed lock in the cloud. So Windows Azure Table, again, you get its, when you create your storage account, you get an endpoint for your table, which is table.core.windows.net. So once you have your account, you can start creating your tables. Once you've created your tables, you can start storing entities in it. These entities are schemaless. It's a NoSQL structured solution. These are schemaless. If you look at the first entity and the second entity in this example, one has rating 2 and the other has a committed field. These two fields are completely different, stored in the same table. So once again, it's a schemaless structured storage. It's a NoSQL solution. We've provided a OData interface to it, so you can use wcfdataservices.net library, or we've also provided you Java libraries to access your data. You can obviously create tables, delete tables, and things like that, or also set ACL. This is a new thing that we've introduced now. So we've introduced something called shared access signatures, which we had for blobs. We introduced it for tables too. So now you can start accessing your tables in a granular manner. Because your shared access signatures, you can say, I want to give only these rows, this partition key range, or this row key range to users. So you can go to that granular detail now with your table. Insert update, all the CRUD APIs are available on table. You can query it. We always prefer single entity lookups for real fast access. But there are scenarios where you need to do some range queries. And so there are some considerations I'll get into in the best practices. So once again, queue, asynchronous messaging, you get its own endpoint. Once you have your account, you can create your queues. Once you have your queue, you can put your message in there. You control the message format, so you can start putting your messages in there. With respect to the queue APIs, other than the create delete queue, we again have shared access signatures for queues. You can enqueue your messages up to 64 kilobytes in size. The queue processing is a little unique from most of the queues in a manner that it is a lease-based, where when you get your message, you give it a visibility time, and then you have to delete the message once you process it. So it's a lease-based mechanism for processing messages. And we provide certain metadata with the queue. I'm not sure how many of you have started using this metadata, which is DQ count. You can use this to process your poison message, or rather remove your poison messages in the queue, or even the message count in the table in your queue itself, which can be used to auto-scale your worker processors that need to process these messages. Because based on the message count in the queue, you can now scale your worker roles that are processing messages. So Windows Azure disks and drives, I said that this is useful for kind of moving your legacy applications to the cloud, for migrating these applications. So there are two kinds. There's this IIS kind, which is basically which was released a couple of weeks ago, earlier in the month, where you can create your virtual machine. Once you've created your virtual machine, you can associate your OS image, which can be Windows or Linux. So you can associate these OS images and also associate data disks to that virtual machine. And now you can just run your legacy applications, which are using NDFS APIs, very easily in the cloud. We always had the past solution, which is drives, where you write your web role or a worker role. And when the web role or worker role starts, you dynamically mount the VHD as a durable drive. And then your legacy application can start using it. Both disks and drives are fixed formatted VHDs. They are page blobs underneath. So the fact that they are page blobs, you get durability, high access, it's scalable, all those characteristics that I mentioned about Windows Azure Storage, you get that. In addition, all flushed and unbuffered writes are made durable. So all your NTFS APIs that you're using, any flushed, unbuffered write will be made durable because we maintain multiple replicas of your data. This also means that your transactions that your virtual machine does, or which you do through your legacy application, will result in API in the driver, the special driver which is sitting in the virtual machine. This is going to send the blob API for put pages or get page ranges or get data, basically. And you pay for these transactions like how you would have if you had written your own application using blob storage. So this is a simple, I'll just quickly go through a blob for those who are really new to Windows Azure Storage as to how simple it is to use it. So once you've created your storage account in the portal, you'll get an account key. All you need is your account name and account key to create this connection string. Once you have the connection string, you can create your cloud storage account. Once you have the cloud storage account, you can create your blob client itself. I then get the reference to the container. This hasn't made any calls over the rest or over the network yet. It's just got an instance of that container. Now I'm asking it to create this container if it does not exist. So this would make two calls, basically or rather this would make one call, which is create a container. If it fails, it's going to make the second call, which will be get container, right? In addition, now I'm getting this blob, which is basically a reference. Again, it hasn't made any calls over the internet. And then I upload the file. And this has transferred the file to the cloud. And if you look at my storage account out here, this is the blob container. This is the container I created, and I uploaded this file, which is around 3 o'clock. This is UTC time. Similarly, you can download the file. These are the APIs that you use. Behind the scenes, they're making these REST calls. And if you look at this, I'm now going to use this application called Fiddler. How many of you have used Fiddler? Awesome. So this is one of the tools that you would need to use to kind of debug what's happening behind the scenes. And so I'm using Fiddler out here, and you can forget what I had run before to make sure that it runs. If I execute this, and I'm going to get 404. It's not authenticated. By default, everything needs a key, right? It needs to be signed. However, if I go back into my demo now, I'm creating a shared access signature. A shared access signature, I give it some parameters like what's the start time, what's the end time, what permission am I giving. And I create this token for the shared access signature. And this is the token now. If I append, if you guys are quick enough to look at this token and try it out, you should be able to access the blob too. Obviously, that's a pretty long token. I've appended to the end of the blob, and I execute again, and now I get the blob. So the shared access signature is what you would use if you want to share your blobs with a subset of folks. You don't want to make it public. You just want to control the access to the blob by giving this token to whom you want to give access to. Or I can make a container public. By making it public, if I go back to this request now, whoops. Let me just wait for this. It should succeed. So even the public access just succeeds. So the previous one was a cached response, so I just executed that again. In addition, there's copy blob. The new copy blob, which is an asynchronous copy. So I want to copy from one storage account in another. So when I do that, I have my source blob, which is in a different storage account. And for this, what I'm going to do is turn on Fiddler so I can capture what's happening. So I need a shared access signature. So I'm trying to copy a blob from another account, right? So in this copy thing, I need to give it an access to saying, hey, I want to copy this blob, and this blob either needs to be public or I need a pre-signed URL. So I'm going to create a shared access signature out here. I'm going to delete the destination blob if it exists. And then what I'm going to do is create a 0-byte blob in the destination. And the reason why I've done this is because copy is asynchronous. When you copy a blob, you have to continuously monitor. As soon as it finishes, someone else could have done another copy, and now because it's asynchronous, you want to keep track saying that, hey, I don't want anybody to overwrite this blob until I've actually verified that the copy is done. So you want to acquire a lock on this destination blob when that copy is in progress. So I created the 0-byte blob and acquired an infinite lease or a lock on this. So now my destination blob has this lease. Nobody is going to, unless somebody calls break, nobody can overwrite that blob once the copy is finished. And then I call the start copy. It returns back saying, hey, the copy status now, this is something new. The copy status now is pending, which means that it is asynchronously being copied. And so I start off a thread to start monitoring it. When I get it here, it's already finished the copy, and so it's not getting into that loop. But if it hadn't finished copying, what would happen is you would see it go into this new method that we provided, which is wait for copy, which is going to just wait for this asynchronous copy to finish, because you will get these properties on your blob which says, hey, this blob has been finished. So this was the previous copy that we saw. Whoops. And this one, I acquired a lease, and this was the copy. In this copy, I had given a SAS signature to my source. And what it said was copy is pending in your response code. When copy is finished, it would now go back and say, OK, your copy source was this. The copy status is successful. This is a copy progress, which you can go and start monitoring, saying how many bytes are remaining. So you can use all these fields that we provided to kind of monitor your asynchronous copy. And so moving on to tables, once again, create a storage account. You get your table client. You create your table. You create an entity. Your entity is nothing but a table service entity which needs partition key and row key. These are fixed properties that every entity should have. This is your clustered index. So your partition key and row key is clustered index. Out here, I have a user entity. So for the user login name, I have the user ID as my partition key. My row key is blank. It's not necessary that you use the row key. So I've set my partition key as a user ID and row key as empty. I created the instance of the class, added the object. Here's another thing. I'm not sure how many people have already started using this. This is meant for your analytics. And what this does is basically, I'm setting something called the XMS client request ID. This is another nugget of information which I think will be useful for end-to-end tracing. What you can do is now you can send a request ID with your request, which will get logged into the storage analytics log. And now this request ID, you can start searching to figure out what happened to this particular request on the server end, on the storage service end. And so you can start, and out here I've added this client request ID. So it's going to save it. So if you now go and look at my storage account again, I have the simple table with this one entity which I inserted. To query, we allow link queries. It's just WCF data services. So I queried for an entity. I updated the block count. So if you look at this, the block count is 0. Updated the object and called save changes. So now when I refresh it, the number of blocks has increased. And so this is a very simple example, but one thing which I wanted to show was start using the request ID. The client request ID will allow you to do this end-to-end tracing, and I'll show you I'll show you the logs in a few minutes because it takes a few minutes to process the logs for it to be available. Going to the next one, which is queue, it's very similar. All the three services are very similar in nature. You create a connection string, create your queue client. Once you have your queue client, you get your queue reference. You create the queue if it does not exist. I'm adding a message out here. And the message, I've said 20 seconds of visibility. I'm going to quickly go through and do a get message. It's not going to return me any messages because I've said do not make this message visible for 20 seconds. So this is a new feature which we added back in November, if I'm not mistaken, where you can now go and add this visibility time while adding this messages. So you can schedule work for a future time. And now I get the message. The thing about this is, if you look at it, so there's one message out here which I've got, and I'd set a visibility time of 10 seconds. So if I look at the DQ count, it says the DQ count was 1. So assume I got this message, this worker role has got this message, and assume it crashes. If it crashes now, you've DQ'd this message. If we did not have this lease, and if we had actually removed the message from the queue, this would have meant that this message goes without being processed. And so we have this lease period where if I just play some debugging trick here and set my next statement, it would get the same message again, and this time the message DQ count should be 2. So this lease mechanism where you set a visibility time while getting the message, you process your message, and then you delete the message. That's how you should kind of think about it, which means that your message can be processed multiple times if your worker role crashes. So make that message processing idempotent. So that's one of the other things that we've normally suggested people to do, which is make your message processing idempotent because of this leasing mechanism. So that was a simple demo. I'll get back to the next one, which is new features. So we released quite a few things, but the best thing maybe with the feedback we've got is the price reduction in transactions. It's a 90% price reduction, and I wish somebody can give me that discount on my home mortgage. It's a 90% price reduction where for 1 cent now you can issue 100,000 calls, which means for your queue message, if you poll every second, you would pay 0.8 cents in a day for every second if you have one worker which is polling. And so this price reduction is something which we've heard your feedback saying, hey, we need a price reduction because we're building scalable applications and it is getting more expensive to build these scalable applications. We've heard you and reduced the prices. In addition, the other common feedback which we had got was tiered pricing. And so we now have tiered pricing with it. The details of all the pricing stuff should be available on our website, and I would really recommend going there to view. There's a pricing calculator out there which you can kind of slide the bar and figure out how much, or rather estimate how much you're going to get charged. In addition to the price reduction, that's not the only thing that we released. We've also released a couple of different ways of storing your data or opting to store your data, which is local redundant versus geo redundant. I mentioned that we always store multiple copies of your data. So we store 3 local replicas in your local primary location as such. These local copies are synchronously maintained. That is, we would not return a success until we are very sure that all the 3 copies have been written in the local stamp. We had introduced Geo last year. In Geo redundant storage, it provides the highest level of durability. In addition to the 3 local copies, once we return success, we asynchronously also geo-replicate your data at least 400 plus miles across in a different region. So we asynchronously replicate your transactions or your data out to the geo location as such. So every primary location will also have the secondary location. Both of this obviously can bear with common failures, because I said that these multiple copies are stored in such a manner that common failures like node failures can be with, there's something called the upgrade domain, and we store it across these upgrade domains, and fault domains, of course. So common failures can be tolerated. If there are major disasters, which is a fire or an earthquake or something of that sort, for local redundant storage, we will contact the customer to say, hey, there may be a potential data loss if you cannot recover the data center. However, for geo-redundant storage, you have the geo-replica, which is 400 plus miles apart, and so we can now recover your storage account from that secondary location. With local redundant storage, there's a price reduction of 23 to 34% based on how much you store. The price remains the same for geo-redundant storage. You may want to use local redundant storage for a couple of reasons. One is that the data itself can be reproduced. So maybe you have some data locally which you had kept into the, which you had moved to the storage solution for some analytics work, and then if it, for whatever reason, if you lose it, you can re-upload your data. Or maybe it's not a critical amount of data that you don't mind losing, because you're going to hedge your bets saying that, hey, is there going to be an earthquake and things like that, right? So you might have other reasons also, which is there are certain laws sometimes which says you cannot store your data in another country or something of that sort. And maybe that's one of the reasons why you opt in for local redundant rather than geo-redundant storage. So these are various reasons why you may want to go and turn geo-replication off in the new portal. By default, when you create a storage account, you get a geo-redundant storage, but you can always turn it off. In addition, we released a new REST API version, which is 2012, 0212. There's copy blob, which I showed you, which is asynchronous copy now, where you can also copy blobs from a different account. Leases, which is an infinite lock, or leases on container, or you can have granular lease time, 15 seconds to 60 seconds. In addition, shared access signatures for your blob, we've removed that time limit which we had before, which is 1 hour of access when all the parameters are associated with the URL and not your container. So we removed that 1 hour limit. In addition, we also have provided shared access signature for tables and queues. This opens this huge scenario where now your mobile applications, where you don't want to start storing your account key on it, can start using shared access signatures to access your storage account. So the new portal now, once you go into your storage account, I'm going to use this one because I haven't configured monitoring for it yet. I can go into monitoring, and let's hope. Oh, I know what's happened. Yeah, sorry, my fiddler was on, and so doesn't work very well with the portal with HTTPS, which I have turned on. But anyways, so you can go and turn off geo-replication out here. You can select off. In addition, I would really encourage, I don't know how many of you have actually turned analytics on out here? Yeah. So I know a lot of people were using storage because I saw a lot of hands go up, but only a couple of them are using analytics. I would really encourage you to turn on analytics because I'll give you certain examples where you actually control your own diagnostics. You get a lot more information out of analytics. And so I'm going to start turning analytics on. This is for your monitoring. And for monitoring, maybe I want to store it for 60 days. This is a retention in number of days, where your data is stored in your analytics for that many days, and then after 60 days, we take care of deleting your data at no cost to you. So you don't have to issue all those requests and start paying for those transactions and things like that. So you can turn on analytics out there. In addition, I'll turn on read, write, and delete for all of them. And for logs, maybe I just want to store it for 10 days. So I better be fast if there's any problems. I only have 10 days of logs. And this is just a number which I picked up. You'll have to figure out how many days you want to retain your logs. And once I save it, this is when analytics is turned on. I had my analytics turned on for another account. The kind of data that you get out of this is basically availability. I've turned on success, but you also have availability for your blob tables and queues. So you can turn this on, and this tells me, hey, for some reason, my blob success percentage was really low. It was just 67%. And so now if I go to metrics and actually start looking at it, I'm going to use Cerebrata's Cloud Studio out here, which is one of my favorite tools. If I go here, if you look at this particular row, I had 151 create container requests, out of which only 1.3% succeeded. If I go back, 98% failed with something called person client other error. Client other error are errors like bad request, or blob does not exist, or container does not exist, or something of that sort. All these expected errors are called client other errors, which is basically it's expected from the service end. From the blob storage service, it's saying, hey, I expected this error because you're trying to get a container which does not exist, or you try to create a container with maybe an invalid name. So those are all these errors that we have. You can then go into your logs. So this is how I use my metrics, right? This metrics data is hourly aggregates. You can figure out, okay, what is your availability, what kind of latency you're going to be, what kind of average server latency you have, and what kind of end-to-end latency you have. The difference is end-to-end latency is the time it takes for us to also send this data, receive data from you, and send the data back to you. Server latency is only the time we took to process your request. And so you can figure out that if the server latency is less and end-to-end latency is large, then maybe something's wrong with your network, or maybe something's wrong with the intermittent network as such. And so you can start to get all this information from analytics. For this particular example, the person client other error, I'll try to go to my logs, and this was around 7 a.m. UTC. So if I go to the logs, let's just try this one. So I had all get blobs out here. So this didn't have create container. Let me see if this had the create container. Nope. Does not. So all the create containers fail with container already exists, because HTTP status code 409. So this is how you can go and start utilizing your logs now. From the metrics, you saw something was wrong. You don't know what exactly. And then when you go into your logs, you're seeing that you have this create container API as such. Going back into the code now, whenever I was uploading a blob into my blob storage, I was doing a container create exist. So every user who comes to my website and is trying to load a blob, I'm first trying to create a container for him. The container already existed. So this is something now I can take it away. If I know the container name, I can take it into an initialization or startup, so I only do once rather than every time the user is trying to upload the blob. So if I comment this out, from there on my availability would increase, or my person success would increase, because I won't get these 409 error code anymore when I try to create the container. And so what I'm trying to say out here is analytics will help you debug a lot of these things by yourself. For example, if you've deleted, we get a few calls like, hey, my container is deleted. I don't know what happened out here. You can go to your log, figure out who deleted the container by which IP address it's come from. So we log your source IP address. So that's another way of kind of diagnosing what happened out there. So there are various scenarios out here where analytics will be really useful for you guys. So I really encourage you to turn that on for your applications. So the key concepts, every object, be it a blob, a container, any object in storage, has two important keys associated with it. One is the partition key. The partition key is important because all objects with the same partition key will be served by the same server. Not stored. It can be stored anywhere in the distributed file system, but it will be served transactionally by a single server. In addition, for uniqueness within a given partition, we also have something called the key of that particular object, which will give it the clustered index. For blobs, the partition key is account name, container name, and blob name. For tables, it is account name, table name, and we have given you an option to control your own partitioning because we feel that you know your application behavior the best. So you can give the partition key value for it. In addition, queues, it is account name and queue name. So this is the partition key for these three objects, which are very important. And then the object key for blob is the partition key and the snapshot time. So if you've taken snapshots, all your blobs and your snapshots are stored in the same partition, or rather served in the same from the same partition. For tables, in addition to the partition key, you have the row key. And for queues, you have the message visibility time, which you control by giving the visibility time period, and a message ID, which we control because we give you a message ID for every message you've inserted. So those are the keys for the objects. All the objects, if you think how they are stored in the underlying system, they are lexically sorted. It's very interesting. 9 is actually greater than 10, because when you lexically sort it, 10 is less, because one in the lexical order, you would have that sorted exactly the opposite. So if you really want 9 to be less than 10, you have to have this fixed length. So you would add 0, 9, and 1, 0. So now 0, 9 is less than 10. So that's another lexical, we use lexically sorted keys. The other thing which is important with these keys is the prefix order is more important in the way they are stored. Look at the table out here on the left-hand side. The blob name, I have the date time. Basically, I have the account name user1, and then the container is logs, and then the blob name, which is timestamp, suffixed with some index. So it's all sorted lexically from your left to right. So you have all user1 records first, and then user2 records begin. Within the user1, within the same account name, all are the same container, so it doesn't matter, but then the blob names differ, and they are lexically sorted. On the table on the right-hand side, your account name is still different. So they're lexically sorted, that the prefix, which is the account name, is more important. And then you have your container name, they're all the same. And then you have the blob name, where that random integer suffix that I had, I prefixed it rather than suffixed it. So now they are not sorted by time. These are two different orderings. And one is actually better for a particular scenario than the other. For example, if I want to sort, I want to get the rows in a lexically sorted way. In the first one, it's naturally sorted. It's all sorted by, for that particular user, it's all sorted by date time. In the second way, I would have to use parallel queries because I have 999 buckets, or rather 1,000 buckets, and then I would have to now lexically sort it within this each bucket. So depending on your scenario, the first scenario is something which we call append-only pattern, where if you keep inserting if you keep inserting based on your lexical sorting, it's called the append-only pattern, which is not very great for scale. It's okay to use an append-only pattern when you don't have this requirement for scale. But if you have a lot of blob uploads, the second pattern, the right-hand side table, actually works much better, where you will randomly hash it into a different bucket, and you'll prefix your name with it. So how does storage scale? So we use range-based partitioning system, and that's the reason any range-based partitioning system, it's just a general statement, any range-based partitioning system will not be efficient for append or prepend-only pattern. A hash-based, there are two kinds of partitioning systems that you can think of, which are common, hash-based and range-based. We chose the range-based because of queries. So this will allow us to, allow us to serve your queries much efficiently, and so we've used that. If you want higher scale and you want a hash base, you can hash your key, because your blob name, which is a partition key, you control it, or the partition key itself, you again control it for a table entity. So you can always build a hash-based system on top of what we provided by the user hashing the key. The system will automatically load balance the data. And so now, hypothetically, imagine that your range of keys is from 000 through 9999. What happens is, when the traffic increases and there are hotspots, our system will load balance. It will split this range. The other thing to note out here, earlier in my presentation, similar presentation, I was told that does it split midway through? It's not midway through. If you look at this, it's not a split in the middle, but it's split based on the hotspots that your traffic pattern creates. So we will split the partition, and now it's being served by two different servers. So your throughput has increased from one server, which was serving the entire range, to now two servers. Your throughput has increased twice, or rather, it's doubled. Similarly, now, once again, our system understands your traffic patterns, the hotspots, it recognizes that, and may split further. And now you would have three servers serving your partition range. And so this is how the range-based automatic load balancing works underneath in storage. So we are a multi-tenant system. With multi-tenancy comes that we need to provide certain isolation. So we have scalability targets in place for this isolation, where we have said that a single storage account can, of course, store 100 terabytes in size, and that's the only size limit you have. You can create how many ever containers you want, you can create how many ever objects you want, but as long as the total space stored in that storage account is 100 terabytes. With respect to transaction limits, you can have up to 5,000 objects per second per account. And with respect to bandwidth, 3 Gbps. And then a single partition, that partition key, all entities that have, all objects that have the same partition key belong to a single partition. A single partition can give you 500 objects per second, or up to 60 megabytes per second. With respect to query, and that's another common question that we get, hey, what happens with the query? With respect to query, smaller scans are more efficient. And by smaller scans, I mean not the amount of result which is returned to you, but the amount of rows that we need to iterate. Smaller scans are more efficient than larger scans, which is pretty, I guess, obvious. But smaller scans will also provide you better consistent performance than larger scans. So if you're building your application and you have certain latency-sensitive scenarios, try to limit the scan or go for a single entity lookup. So that would be a piece of information while building your application. With respect to best practices, your storage account itself, we went over the scalability limits. Co-locate your storage accounts within your compute roles. So if you have your compute roles, your web worker, your VM role working in, let's say, Europe North, then co-locate your storage account out there because egress is free within the same region. Use multiple storage accounts when you need to scale beyond that target of a single account. Or you have client proximity. So your web application has to run all over and your clients are all over the world. Then you may choose to now have multiple storage accounts. You'll use the storage account in Asia for your the customers in Asia and storage accounts in Europe for customers in Europe. So you would choose that based on proximity. If you're building an application which is targeting multiple clients, you don't have to create multiple storage accounts. You can create a single storage account and then maybe create a container per client. Or if you're storing table data, you might choose your partition key as your client ID or something of that sort. So you don't need a storage account when you're targeting multiple clients. It's basically your scale targets and your client proximity that drives into how many storage accounts do I need. When you design your application, you should also think about, OK, if I need multiple storage accounts, how do I increase the number of storage accounts tomorrow if I need to scale even more? So common practices, you have consistent hashing. That's one thing. Or you can also do a lookup based, where you would, every client ID that comes in, you will say, OK, this is where your storage account is, and you'll have this lookup table. If you have 1 million customers, you still have just 1 million entities that you need to cache, which will easily fit because this is just a redirection lookup table that you have. And so you can use caching out there for this fast access to go to your storage account that has that data. When you turn on your Windows Azure diagnostics, which is different from storage analytics, when you turn that on, use a different storage account because when you turn diagnostics for your web app, your web application or whatever it is, use a different storage account. The reason is because you want it to be in a different namespace than your production data. That's your diagnostic data. So anything, because we've seen customers sometimes have logged a lot, it's very chatty logging information initially, or they want to debug a problem. And if it goes to the same account where your storage account is, it may impact because of your multi-tenancy, which is your diagnostics and all your client data are stored in the same storage account, it can get impacted. So it's better to use a different storage account for your diagnostics. Choose local redundant storage. We've already gone over it, either for non-critical data or if you have certain rules because of which you cannot store the replica in a different country. Common design and scalability. With respect to .NET itself, there are quite a few settings, and then there are some network settings too. Turn off nagling and expect 100. These two can be turned off for better performance. You can use Wireshark to actually see that you would get better performance, especially with nagling out there. We have a blog post which has more results, or rather associated with it some results or experiments that we've run. Set your connection limit, and this is very specific to .NET. .NET has a limit of 2 by default, unless it's a web app, in which case I think it's 12 times number of cores. But it has this default connection limit, which you might want to change for your application. Turn off proxy detection when you're running in the cloud, especially in .NET, because you don't want it to, your startup will be very cold until the proxy is detected. So that's something which you might want to turn off auto detection. Distribute your requests across the range that you have rather than creating just a single hotspot. Because if you create a single hotspot which is in a single partition range or single partition, then it's very difficult for us to load balance. Because all entities with the same partition key will have to be served by the same server. So the best way to scale is to avoid append and prepend only patterns. Basically, these are requests targeting your objects in a lexically sorted manner. So this is the example which I had previously as an append-only pattern, where you use date timestamp. It seems like, okay, yeah, each object is a different partition key. But when you start inserting in this lexical order, no matter how many times we load balance, it's not going to impact you, because you'll always go to this last range that was created because of the append-only pattern. Perform your one-time initialization, like creating containers or setting ACLs, in your startup rather than every time an operation is performed. This will reduce the number of transactions that you have. Yes, the transaction price have been reduced, but each transaction is a round trip added to your latency. So for better performance systems, you may want to reduce the number of round trips. Use caching for latency sensitive scenarios. So if you have certain piece of information that is rarely changing, cache those. Rely on caching rather than doing a round trip to the storage solution. Use appropriate retry policies for intermittent errors. When we load balance, you might get server busy. So if you retry your operation, the likelihood of that request succeeding increases. So use retry policies to kind of get past all these intermittent failures. With respect to blob design scalability, how to upload a single blob fast? Use parallel upload. So you can set this setting, and you have these parallel requests that are uploading all the blocks. How to upload multiple blobs in a single container as fast? This is bandwidth. The previous one was latency. This is bandwidth. You're more interested in bandwidth. Upload multiple blobs, not necessarily in a lexically sorted way, but upload these multiple blobs in your container simultaneously for getting more bandwidth. How do I migrate my blobs between storage accounts? Now we have the copy blob API, which does it in an async fashion, so you don't need a worker role which is pulling out this blob and storing it into the new container. So to avoid the append-only pattern, what I could do is list all the various containers in my source account. And then with various containers, I can start uploading them in parallel. And that avoids the append-only pattern. The other tip out there is to start using CDN. If you're kind of targeting this various, if your target audience is spread around the world, you can use CDN to make sure that you efficiently provide this blob to your end user. One of the things that we will be working on is to remove this append and prepend only limit for blobs. It's just for blobs that we would say, okay, now you can start uploading without thinking about append-only pattern or not. The reason why we are saying only for blobs is because blobs have this logs that you might want to start uploading using date timestamps, and from our end, we may have an efficient way of getting rid of this limit of append and prepend only patterns for blobs. With respect to queue design and scalability, use visibility as a lease on a message. So use short leases. When you do a get message, you're going to use this visibility time as a lease. You can use short leases, and then there's this update message which we released last year. You can use that to extend your lease. The reason is, let's assume you feel that you need 1 hour to process your message. If you use this lease time of 1 hour, your worker role gets this message and then crashes. For 1 hour, nobody can pick up that message again. So you may want to use shorter lease times and then use update message to kind of go ahead and extend this lease. Make message processing idempotent. You can use batch get to increase your throughput, so you can get 32 messages at a time. Use the message count to scale the number of workers that you need to process. So if your queue, and this is another thing where analytics will help you. If you see that in your analytics, your number of get messages like exceeding 10 times, or rather 100K or whatever it is, but the number of put messages just very few, it means that you have a lot of workers that are doing this unnecessary calls. So you can go and reduce the number of worker roles that you have, which is doing this message processing, because your queue doesn't have that many messages. So most of the times, it's not getting any messages out. So in your analytics, get messages, put messages, you can see how many requests you're making. If there's a large discrepancy, it means that you need to do something, either scale up or scale down. Use DQ count on your message to handle poison messages. Poison messages is something which your worker role does not understand this message. It always crashes whenever it retrieves this message. So you can start using the DQ count. And based on your DQ count, you can say, OK, I'm not going to process this message anymore. I'm going to store it in a separate table so that somebody can go and look at what happened to this message. And so your queue makes some progress then. If you have this long processing, you can, for your queue messages, you can use update message to store intermittent state. And this is also a way of implementing your process flow or your workflow. Message sizes are 64 kilobytes in size. So if you want to store something larger, then use blob storage to store that message. And then the URL will be stored in the message itself. So there's a level of indirection out there. You saw that the queue name was a single partition key. Account name, queue name was a single partition key. So queue is a single partition. It won't be load balanced based on how many messages per second you have for that single queue. So the way you scale beyond that limit is use multiple queues. So you can go in a round-robin fashion to put messages and to get messages. Table design. So we have a NoSQL store. And what NoSQL is basically a paradigm shift. Rather than thinking in terms of joins, rather than thinking in terms of relational data, highly normalized data, and rather than thinking in terms of stored procedures, you think in terms of how do I shape the data so that when I want to retrieve it, I can do it very efficiently. So there's a paradigm shift in the way you start to think about table design. But the design, the way you start designing for it is almost very similar. You would first list out all the critical queries that you have for your scenario. You would then look at which entities would need transactional semantics. Like, for example, if I want to upload a blog and also update the number of blogs on the user account, if these two entities are different tables, there's no way in Azure table to do this in a transactional consistent manner. So I might store these two into the same table, use the same partition key. Now I can use entity group transaction to update the block count on the user and also insert a new blog. So you might start thinking in terms of entity group transactions in your design. So these are very similar things that you might want to do also in a conventional system. User queries need to be fast. That tells you what your index should be. And then in addition, what are the transactions that you want? And that would also play a role in selecting your partition key. And I have an example out here, which I was asked for on a flight to Amsterdam as to how would you choose your partition keys. And I'll go over that example out here. The other thing is it's schema-less, so that's why you can store multiple entities. But the thing is, you have a clustered index. You have one clustered index. We don't have secondary indices. We have one clustered index. You can store multiple fields in that clustered index by concatenating it. And I'll show you an example for that too. Be aware of locality, entity locality. How is the entity sorted? Partition key, row key. So be aware of how it is. And again, I have an example which will just let you know what is best for your design as such. From your query performance, single entity lookups are the best. When it gets to queries, it's not the number of entities that are returned, but it is the number of entities that we have to scan on the server end, which plays an important role. I'm not downplaying the effect of serialization over the network. If you get 1,000 entities, yes, it will have more latency than a single entity. But that was obvious. But the other thing which should be obvious, but sometimes is not, because you don't think how these entities are stored on the server end. And so maybe you don't have that insight yet. And so that's one example I'll show how you can have this insight into how your sort order is. So order of performance, single entities. Second, small scans. And then large range queries. The other tip out here is do not reuse data service context across operations. change your data service context. If you're developing in .NET, change your data service context. Use one single data service context for a given operation, for a given logical operation. If you want to update an entity, the logical operation is you get that entity and update that entity. You might use the same context for that. But if you're updating two customers and these are two different logical operations, do not reuse your table service context, because table service context is not thread safe. So the data service context, basically, the WCF data service.net, the .NET library is not thread safe. So the demo out here for the table design is basically I have my users. Users have blogs, and each blog may have multiple comments. I want to store this in Azure Table. How do I design for it? There are multiple choices, and different scenarios, different design may be optimal for it. But I'm going to take a few more requirements. I want to track how many blogs he has, a given user. And so if I want to track how many blogs a given user has, it means I need a block count on that particular row and user entity. So my user entity will have username, password, and all the usual stuff. In addition, I might have a count on it. My blogs will need a comment count. So similarly, it needs to have a comment count on it. And then I have my comment entity itself. Since I want to maintain these counts, and there's no efficient way of retrieving counts, what I will do is I will store the count with the user entity, the block count, the comment count on the blog entity, and I'll store all these entities in the same table so I can use entity group transaction. So whenever I'm updating a blog, inserting a blog entity, I'll also update the count on the user entity in a single transaction, so it's all or nothing. So if I go out here, I have my base entity which has partition key, row key, entity type, and created on, because user I need when was the user registered. For blog I want to know when was that blog created, and for comment I want to know when it was created too. In addition, for the user entity I have the user fields out here and the block count stored out here. For the blog entity, I have the blog URL and comment count. One of the things is, what is a partition key? The partition key seems like user ID will work, because when the user logs in, I always want I want the blogs for that particular user. So the user ID seems like a good partition key. What should be the row key? For my user entity, I'm not going to use any row key because there's nothing. It's a single user entity. That's about it. For blog, however, I have two options. I can set the blog ID in there, or I can prepend that blog ID with a constant which says it's a blog. So I can prefix it with blog and the blog ID. For the comment, my partition key is again user ID. But the row key, I can have the blog ID as my row key and append it with the comment ID. Or the other option is I'll have the comment type, and then I'll have the blog ID and comment ID. So I'll concatenate these two. So let's see how the data is stored. I've already populated this. I have two tables. Just going to close this. So in my single table, I have my user entity, which I've highlighted, and then all the blogs that I've posted. The fact that I have prefixed it with blogs means all my blogs are stored together. So this is very efficient if I want to retrieve all my blogs for a given user ID. And then if I want all the comments for a particular blog, they are clustered together, because I have the blog ID and comment ID as a row key. The partition key is always my user ID. For multiple users, and I'm pretty sure I have more users out here. This is a different user. So I have all my user ID entities and then some other user's entity and so on and so forth. My other option, as I said, I'm not going to prefix it with the type. I'll have the blog ID. So this is my blog entity. This is my user, sorry. This was a user query, but user node type view is here. I have my user entity here. This is my blog entity. And then all the comments for that particular blog is next. So all these are comments for the blogs. The fact that I didn't have the type prefixed in my row key means now I have my blog and then all the comments, which means my query, which is list all the blogs for that particular user, is slow. Because I have to iterate, the service will have to iterate all the blog, all the comments associated with that blog, and then go to the next blog. This is the exact natural sort order that you would see stored on the table storage side. Your data is sorted by partition key, row key, and so they are sorted in this particular fashion. And so now this query, which is get me all my blogs, is slower because it has to iterate through comments too. However, if your actual query that needed to be efficient was, for this blog, get me all my comments, and I'm never going to list all blogs, then this fits well. Because now this is kind of a poor man's join, and this is what I was showing out here, which is for this particular blog, get me my blog entity and all the comments associated with it. So this is kind of a join where I'm getting my user entity, my blog entity, and all my comments associated with it in one single query. Right? And so this is fine for such queries, but it's not fine when you want to start listing all your blogs. If you go with this particular table, the way you would do to retrieve all the comments associated with that blog is use that blog ID and then make another query which will go get all the comments. But it's still fast. It's fast because now you're giving it, saying, hey, I want the comments out here. So these are your two design choices that you have. And based on what your requirements is, one is more efficient than the other. So this is what I meant saying that understand how the data is stored, lexically sorted with your partition key, row key, and then utilize that information based on your user scenarios to design your partition key and row key. Make use of your clustered index, though. So with respect to shared access signatures, I have a few minutes left, so I'm going to go fast out here. Use HTTPS to kind of transfer your token. Use your minimum permissions associated with it. It's kind of obvious. You don't want to give a write permission when you don't intend to, but use the minimum set of permissions that you need and restrict the time period. Beware of clock skew, because you might have created shared access signature using your clock on your node, but when you give it to someone else, and if they have a clock skew, it might not work. So you want to go and update the kind of the expiry, or you want to update this shared access token much before the expiry. For revocable SAS, which is basically you can store all this in a container, and give a policy ID associated with it for your shared access signature. For such revocable SAS signatures, when you want to kind of delete a policy ID and recreate, do not reuse your policy ID names, because you might have given this out to someone else with that same policy ID. Only 5 policies can be stored, but use different names. Diagnose your storage requests. Take control of your diagnostics. Wireshark and Fiddler, they are your friends. Use it, because you can really diagnose all the problems, most of the problems on your end to figure out what's happening. Turn analytics on. We saw how to turn it on. Analytics data is stored in a different namespace than your storage account. So it does not, the limits of accessing your analytics, or rather the limits of the server storing your analytics data does not affect the limits that we have for your storage account. It's in addition. So there are different namespaces. Learn from your application behavior, because this allows you, like, for example, hey, I had create container every time a user uploaded the blog. Why do I need it? Or I have more get messages than put message. Maybe I need to scale down my worker role. So all these things, learn from your application behavior and improve it. And also monitor your storage account. The end-to-end tracing, where I could now add a client ID and then figure out what happened to it on the server. So that it enables that. And then the portal allows configuring for analytics, of course. Turn on retention policy. We saw that retention policy actually helps you get rid of your old data. This is the last slide which I had, and one of the things that I wanted to show was the client request ID. I have this particular ID out here. And if you look at it, your client ID is stored in your logs at the end. So this is how I can go and see what happened to that particular request that I issued. If there was a network failure, I can still say, okay, yeah, the entity insert actually happened, and that's why my second insert failed, right? So all these things are logged in your logs, and so you can go and make use of this to improve your performance. So back to the screen. So turn on analytics. I know I'm repeating this like the 1,000th time, but seriously, I mean, this has been out for a year, and this has helped a lot of customers improve their application by learning from all these metrics and logs. In terms of future direction for Geo, the thing that we will be working on is read from secondary. We will allow you to start reading from the secondary. Today, the secondary, you do not have any endpoint to access that data. Unless there's a Geo disaster, then we control the failover and things like that. The second feature we will be working on would be control your own failover. These are not in any of the priority lists, but these are the things like you can start controlling your own failover so that you can test for compliance reasons or to figure out how does your application actually handle failover. Your web app, does it handle this failover very kind of transparently or not? So you can start testing these things out. And then we, of course, will have SLA for geo-replication in terms of recovery point objective and in terms of the RTO. We will also have the 1.8 client library and storage emulator. This will ship with the next SDK. Unfortunately, the official SDK release that we had does not support the 2012 version because the client library code complete was long before the cloud service was updated. So, however, we have links in our blogs to GitHub where we open sourced our what we call as 171, which has all these new features that I've used for the demo. So the copy blob and all these new methods are available on GitHub. You can download the source, build it, and use it. We will also be building a better parity emulator. Our table emulator today is built on SQL, and there are a lot of limitations based on the ADO.NET data service library version. And so we're going to kind of up that version and or rather increase the parity with the cloud solution. How many of you actually knew that we have a blog site for storage? Okay. If you're developing with storage, I would really keep this in one of your links where you go and figure out if there are any new blogs, because all the features and all our best practices and things like that are there on this blog site. Pricing information, getting started, has all these or rather simple examples. And of course, we have the storage 171 on GitHub. So these are the track resources. Please submit your evaluations. That'll help me. And also with your comments as to what you would like to see more or what you would like to learn more. Questions? And if I think I'll be kicked out here very shortly. But I will be outside out here or at the booth too if you have more questions. I'm not sure if the next speaker is already waiting outside. Yeah? Pardon? Good question. We do not have a native SDK yet for storage. It's something that we are looking into. We are trying to kind of figure out how many. The first thing that we would do with 1.8 is actually have a WinMD solution for storage libraries for Windows 8, for Metro apps and all that stuff. That would be released first, but we don't have we don't have a native library yet. Right? Sure. Right, right. When you have frequent access, and how do you, if anything changes with the E tag, how do you kind of, sure. We can go over that. It might take a few more minutes, and I'm pretty sure we'll have to leave this room with the new speaker coming in. But yeah, we can surely take that offline. I would love to sit with you and figure out what your requirements are in terms of that, and how you can, with this optimistic concurrency, how you can kind of have concurrent writes as such. Definitely.